Have you ever looked at your JavaScript code and yelled, "What on earth is this?" Literally, the word "this." It's okay to admit it. The "this" keyword in JavaScript caused more existential crisis for developers than CSS centering. 1 minute it points to your object, the next minute it's pointing to the global window, and suddenly your app is broken and you're questioning your career choices. But today the nightmare ends. By the end of this video, you're going to master the 4 secret rules of how JavaScript decides what this actually means. You'll be binding context with the precision of a master sniper. Stick around because rule number 4 is usually where everyone gets tripped up. Let's get into it. Alright, before we look at the rules, let's understand the core problem. In English, the word "this" depends entirely on context. If I say "look at this" while pointing at a slice of pizza, this means pizza. If I point to my cat, this means a fluffy ball of chaos. JavaScript works the exact same way. The "this" keyword is like a shapeshifter. Its value isn't determined by where it is written. It is determined by how the function is actually called. To keep our sanity, we use 4 simple rules to figure it out. Let's head over to the code editor and break them down. Rule number 1 is default binding. This happens when you call a plain standalone function all by itself. Let's write a quick function. Here I write a simple function, say hello, which prints this in the console. And then I call it. I save this and let's see. Click on inspect and then go to the console tab. It prints the window object. Because the function was called in the open with no owner, JavaScript defaults this to the global object. If you use useStrict at the top of your file, this will actually be undefined. It's JavaScript's way of saying, hey, you didn't give me a context, so I'm giving you nothing. Harsh but fair. Let's also see it in action. If I add useStrict and then save it, you see that this time we get undefined. Rule number 2 is implicit binding. This is the one you'll see 80% of the time. When a function is called as a method inside an object, look closely at who called it. So now I declare a variable, an object, person, which contains name, Harry for example, and age 18, and also a function, introduce a function which simply logs a message to the console. Here I use backticks and templated roles. My name is this.name and I am age years old. I save that and let me also call this function person.introduce. I save it. Now what do you expect to see in the console? I click on inspect and go to the console tab. Yeah, my name is Harry and I am 18 years old. Look at this line. Who is immediately to the left of the dot? It's person. So inside that function, this implicitly binds to the person object. Easy peasy, right? But what if we want to force JavaScript to use a specific object as this, even if that object didn't originally own the function? Enter rule number 3, explicit binding. JavaScript gives us 3 magical tools for this: call, apply, and bind. Let's say Harry has a friend named Ron who is also 18, but Ron doesn't have an introduce method on his object. He's a bit shy. Here, another object, friend, which has a name property, Ron, also an age. Then I can do something interesting. Person.introduce.call, and then I pass Harry's friend to this method. Let me comment out this line and save that again. Here you see that my name is Ron and I'm 18 years old is printed in the console. By using .call, we are explicitly telling JavaScript, hey, grab Harry's introduce function, but forcefully hijack this and point it to friend instead. Now Ron can introduce himself using Harry's code. You're welcome, Ron. Finally, rule number 4, the new binding. When we use the new keyword to construct a brand new object from a function, JavaScript does some behind-the-scenes wizardry. This time, I add a function, hero, which takes argument name, and then using the this keyword, we set the name to the name coming from outside. So this name on the right side of the equation is the name that we are getting here. Then I declare a variable, const Avenger, for example, and then, this is the important part, using the new keyword, I pass a name to the hero function, for example, Iron Man. Then, let's print it in the console, Avenger.name. I save this, and you see that Iron Man is printed in the console. When JavaScript sees that new keyword, it secretly creates a brand new empty object and links this directly to the new object. But wait, there is a plot twist, a villain in the JavaScript universe that breaks all 4 of these rules. Arrow functions. Arrow functions do not have their own this keyword. They are thieves. They steal the value of this from whatever code surrounds them lexically. Let's look at a classical bug that ruins developers' day. Let's declare a variable const car. It's an object that holds model to Utah, for example. Also a function log model. This is an arrow function. Prints, again backticks and templated rows, this dot model. I save this, and here let's call this method log model. I save this, and let's see. Undefined. Wait, what? It's undefined. But rule number 2 set to look to the left of the dot. Car is to the left of the dot. But because log model is an arrow function, it ignores the object call completely. It looks outside of the car object into the global scope, where model doesn't exist. So remember, never use arrow functions as object methods if you plan on using this. And there you have it, the 4 rules of this plus the arrow function trap. Let's do a quick mental recap. Rule number 1, default. Just a regular function, global object, or undefined. Rule number 2, implicit. Look to the left of the dot. Rule number 3, explicit. Call, apply, or bind. Rule number 4, new. The new keyword makes a fresh object context. If you found this breakdown helpful, hit that like button and subscribe, so the YouTube algorithm knows you are a cultured developer trying to level up your skills. Until next time, keep coding, keep learning, and as always, stay awesome.